All right, so chapter 3, here we go. So we are going to multiply and divide radicals. So what you've seen already is you've seen that if I've got or a number that is a product of two numbers inside of a root, I can separate those into two roots. We can also do the reverse. So if I've got two roots, they're the same, square root, or cube root, whatever, I can combine them into this similar thing. So we're going to be using that. You saw that last time a little bit. And also what we're going to do is we're going to deal with something like this. So you've seen 2x times 3x. You know you multiply the two numbers together to get 6. You go x times x, it gives you x squared. We are going to do a very similar thing. So instead of x, now notice we've got square root of 5. So 2 times 3, that gives us 6. And then root 5 times root 5 gives us root 5 squared. But if I have the square root of 5 times itself, or squared, it's going to be 5. So this square root 5 squared is going to just be 5. The square root and the squared cancel. So 6 times 5 gives you 30. This is what we're going to be dealing with in this section. At least a little bit. It'll get a little bit more complicated here as we move on. So here, the roots are the same. So I'm going to multiply the first and the last. 4 times 3, that gives me 12, times root 5 squared. Root 5 squared, that's simply 5. So 12 times 5, that gives you 60. I don't have the completed notes as I go through this, so I'm going to try not to make any multiplication errors here. And that's the same for all of these that we can do. You don't need to show all these steps. I'll show you what you can do. So root 2 times 4, negative 2 times 4 gives you negative 8. Root 7 times root 7 gives us root 7 squared. That gives you 7. So negative 8 times 7. So that will give you 56, negative 56. And there you go. So that's not too bad. Not too bad when you have that squared term there. Let's try some that actually don't have the same root. And let's figure out what we can do with this. So we'll still be able to do the same thing. We're just going to have to do a little bit more here. So we'll still multiply the numbers in front. So 4 times 3. I'm gonna choose to write this out explicitly so you can see this instead of just hearing me say it. And then root 3 times root 5, like such. So when I do this, 4 times 3 gives you 12. Root 3 times root 5, I can combine that underneath and do root 15. So this is going to be our answer. Again, sometimes we might have to pull out a perfect square. In this case, there is no perfect square in here, so we're just going to leave it. But always at the very end, double check and see, can I take out something from here? Unless you're asked to turn a mixed radical into an entire radical. I'll show you one more step here. So here we go. 3 times negative 2 gives you negative 6. Root 2 times root 3 gives you root 6. So something like this, you don't really need to show the steps. You can just put like this. But on the test, you can show your work like that. So let's do some now that when we multiply them, we're going to need to take out a... Sorry, I'm waiting until this vehicle outside stops revving his engines. You get the authentic experience of everything that's going on the outside. It's like when I talk to people on Zoom calls. You always hear something going on in the background, and that's okay. Everyone's got that. Seriously. Well, I'm not going to wait forever. I'm just going to keep going. If it's too loud, I apologize. So let's multiply these out. So multiply 2 times 3, so that's going to give me 6, and then root 3, 6 times root 3. So when I multiply this, 6 times root 18, notice I can take out a perfect square from this. I can take out root 9 from this. So this would give me 6 times 3 times root 2, which 6 times 3, again 18, times root 2. So you will notice sometimes this is what's going to happen, is you might end up having to simplify at the end. Let's try this again. Multiply the numbers. 2 times 3 is 6, times negative 2 is negative 12. Then in the root we've got 5 times 5 times 5. So even before I multiply these together, this one's pretty easy. Notice I've got root 5 times 5. That's already a perfect square. So I got root 25 and root 5. This just gives me 5, so negative 12 times 5 times root 5. 12 times 5, negative 60 times root 5. So even if partway through you can recognize something like that, that's totally okay. You can get an answer like this. I'm going to move on to the next example here. So even before you multiply these, sometimes you can recognize that you can simplify beforehand. For instance, here I've got root 8. I can simplify that even before I multiply them out. Yes, you could multiply it and then simplify it. This just saves you a little bit of hassle at the beginning when you're dealing with smaller numbers. So I can simplify this one. Get negative 2 times root 4 times root 2. And this is still times 3 times root 2. Simplify this. Negative 2 times this, which is 2. You get negative 4 times root 2. As such. And now I can multiply these together. Negative 4 times 3 gives me negative 12. Root 2 times root 2, so this is root 2 squared, which is really just negative 12 times 2, which equals negative 24. So by doing this before, it just saved me some hassle. So you might as well just start off with that. I'll show you another example here. Notice here I can factor out a 4 from both of these roots. So I can simplify both of them before I start multiplying. So I factor this into root 4 times root 2. Here, this is root 4 times root 3. So 2 times root 4, which is just 2, so I get 4 root 2 times 2 root 3. Multiply this out. 4 times 2 gives me 8. And then root 2 times 3 inside the square root, you get 8 times root 6. And there's your answer. Simplified even before you made it more complicated. So that is example A. So let's switch over to the next page. Just kidding, we still have part A on the other side here. So let's continue on with this. We could do the exact same thing with cube roots. You'll notice that there's lots of times we just tag in this cube root. We could do the exact same thing for something like this. So let's multiply this out here. Cube root 2 times cube root 4. Multiply that inside the cube root. Since it's both cube root, you get cube root 8. But this is a perfect cube. It just equals 2. Okay, that one was pretty easy. That one didn't require a lot of thinking. Let's try another one that maybe does require a little bit more. So let's try this one. Multiply all the outsides. 2 times 3 times 1, so we get 6, times the cube root of 3 times 3 is 9. 9 times 6 is 54. But notice with this, I can factor out a perfect cube with this. And if you don't know what the perfect cube is, you can just try and divide it. So we get that see, we can take out a perfect cube of 27. Yes, I did just try that on the calculator just to double check. So I can break this up into the cube root of 27 times the cube root of 2. This is 6 times 3 times the cube root of 2, which is equal to 18 cube root of 2. So that's how you do this. Always double check at the very end if you can take out another cube root. That would be very helpful. We can also do this now with fractions instead of just multiplying. So we are going to try and combine terms here and simplify and see if anything happens. So for example, this one, we have got that the cube root of 35 over the square root of 7. Neither of these are perfect squares, so I can't simplify that. However, I can put this under a single root and get this. And now what I can do, 35 divided by 7 just gives me the square root of 5. So this does simplify, even though it doesn't seem like it. So you'll want to actually try this and put it together under a square root and see what you get. So we can do the same here. Under the square root, 56 over 7. You can actually divide that. You'd get the square root of 8. And there's your answer. Except I can simplify this. Anytime you can simplify it, simplify it. So I can factor out root 4. Always, 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 always double check and make sure that you can see if you can do something like this. Not always. Sometimes you'll be able to. All right, so let's try a different one here that requires a little bit more. Let's do E here. So the numbers outside you can divide, but there's nothing I can really do with that. So I'm going to leave it as negative 4 over 3, doesn't matter where you put the negative, times square root of 54 over 12. So with this, you can simplify what's in here. You're not going to be able to simplify it completely to a whole number like we did before. However, we can still divide these for sure by, let's see, what can I divide this by? I can divide them both by 6. So 54 divided by 6, that gives me 9. And 12 divided by 6 gives me 2. So I've got this. And yes, technically you can get here, but I can simplify this even further by realizing the square root of the top number. I can actually get a whole number. So negative 4 over 3 times square root 9 over square root 2. And the square root of 9 is 3, and there's a dividing by 3 here, so those cancel. So I'd get negative 4 over root 2 like this. Now, I believe there's something I'm going to teach you a little bit later on about this. Yeah. So in the next lesson, I'm going to teach you something about this. This one is actually not complete. I'm not going to go into that now. However, be aware that you don't want to have a root down at the bottom. So there would be actually something we would do in addition to getting rid of that. But that's something that I'll get into a little bit later. So that is this lesson. Oh, there's one other thing I wanted to share with this. I forgot. Remember, we said for some examples up top here that you can simplify. So for example, this other page, we said you can simplify this first before you multiply. You can do the same thing with dividing. You can divide, or you can simplify before you divide. For instance, this one here. You'll notice up at the top, I can actually take out a 9, right? Square root of 9. So this would give me 6 root 9 times root 2 over 2 root 6. So I'd get, and I can simplify this. So 6 divided by 2, this just gives me 3. So 3 times 3 up here, give me 9, root 2. Actually, I'm going to put this all under the same root. So 2 over root 6. I can simplify that. We get 9. Let's see, 1 square root of 1 over 3, which simplifies down to 9 over root 3, because root 1 is just 1 times 9 gives you this. Again, the denominator cannot have a square root in it, so these two are not finished, but I'll show you next class what to do with that. But that is all I'm going to cover for this section. Let's see, is there another example up here? Nope. We'll cover section C in the next class.